All right, so we have a question here that says a train travels 110 miles in the same time a plane covers 528 miles. If the speed of the plane is 10 miles per hour less than 5 times the speed of the train, find both speeds. All right, so here's a word problem that we're going to have to break up and just try to dissect and understand. So you can see here that we are working with distances and speeds and times. One thing that I would use right away is just the fact that we know that a distance traveled, let's just say d, is always going to equal some kind of rate times a time. Distance equals rate times time, or distance equals speed times time. And we're just going to read through this and see if we can use that equation to write out some statements here, right? So if you look at the first sentence, a train goes a distance of 110 miles. So if we think about, let's just think about the train. The train is covering a distance of 110 miles, so I'll plug that in for D. The rate of the train, we don't really know, so I'll just say rate. And the time, we don't really know, so we'll, I guess, just keep it like that for now. So I have this train, and there's a little equation there which doesn't really tell us too much, but we know the distance is 110. You think about the plane, right? We also have the plane. And if we put that into the equation, we know the plane travels 528 miles, and that can be broken up as a rate times a time as well. Okay, so we start there pretty basic, right? So we kind of have two equations, and if you think about what this question is asking for, look to the last sentence there. It says find both speeds. So that would be, I'm trying to find the rate of each one of these equations. So, all right, so we need to dig into it a little bit further. Okay, so we have two equations, and let's think about the variables in our equations. First of all, time. Okay. Time in each one of these equations, one for the train and one for the plane, we don't know what the time is. Okay, we know that the time is the same though. So as we start to transform these equations, we want to replace these unknown values with just variables to make it easier to write. So we could just take time and we could just call that, why don't we just call it t, variable t. Instead of time, I'll just put a t there. And then we can kind of go through each one of these rates, or each one of these unknowns, and also put a variable to it as well. So how fast is the train going? Again, we don't know what that is. Okay, it's some kind of speed. So just for simplicity here, why don't we just take that and we'll just call this x. Okay, we'll call that x, and I'll put my variable definitions over here. So t is going to be the time that both the plane and the train are traveling for. We're going to say that x is going to represent the speed of the train. And over here, this rate, the speed of the plane, we also don't know what that is. So why don't we call that y for now? So we have y is the speed of the plane. Okay, so typically when you do some word problems, you might just have a little bit of kind of a rough draft here. You kind of write out what you know. We use this equation to start to format and organize our information that we have and just to show the relationship. So now as we break this down a little bit more, let's rewrite our equations, okay? So now we know that 110 equals xt, right? X times t, because that's what we defined it over here. And we know that the plane is going to be 528 equals yt, okay, with the variables that we used. Okay, great. So again, we're trying to find x and y here. We have two variables, or sorry, yeah, we have three variables here, x, y, and t, and we only have two equations here. So if you think about a linear system, typically if we have two equations, we can usually solve for two different unknown values by solving the system. Here we have two equations, but we have three unknowns. So we're going to have to use other parts of this problem to fix that. And we can look at this sentence right here. It says, if the speed of the plane is 10 miles per hour, less than 5 times the speed of the train. Okay, so we sort of are going to take this yellow part, this information, and write out a relationship there. This could give us another equation that could be useful. So the speed of the plane, it says the speed of the plane is, okay, that keyword is usually translates to an equals, right? Because you're saying something is something else, and that's usually a sign of equality. So the speed of the plane is y, right, in our variables here. So we're going to say y is equals 10 miles per hour less than 5 times the speed of the train. Well, what is 5 times the speed of the train? Well, that would be 5x right here, because speed of the train is x. And if we want 10 less than that, it says the speed is 10 less than 5 times the speed of the train. So that would be minus 10. So this yellow bit of information is basically telling us this right here. All right, so looking back to kind of our first two equations, right? Remember, we're trying to solve for y here. Well, we didn't really solve for y yet. We solved for y in terms of x. But this is going to be helpful because we can now take this, and since y is equivalent to 5x minus 10, we can go ahead into our little equation there and substitute in 5x minus 10 for that. So instead of that, we'll have 528 equals, we're going to say parentheses, plug in that 5x minus 10 times t. And so there's our new equation. So let's look at the equations that we have now. We still have 110 equals xt, and now we have this other equation, 528 equals 5x minus 10 times t. And so now, if you look at those two by itself, this is like a system of equations. Look at these two equations, and there are only two variables. So we can solve this with substitution or elimination. And then we'll be able to solve for one of the variables. So let's just go ahead and use substitution. Substitution probably easier here. So substitution, we just solve for one of the variables in one of the equations. So let's look at this first equation. Let's say we solve for x, right? So if I solve for x, I'm going to divide both sides by t. So that means that x has to be 110 over t. Okay. So if I know x is 110 over t, I'm going to go ahead and plug in 110 over t into my bottom equation. So if we do that, what do we get? Got to do all the algebra here now, but 528 equals 5 times 110 over t minus 10, and this is all times t. So we go through this. This is going to be 528 equals, this would be 550 all over t minus 10, all this times t. Now, we haven't done this yet, but if we're going to simplify this right-hand side over here, we can multiply or distribute that t in. So let's go ahead and do that. Multiply this t in to each term inside the parentheses. And I'm going to rewrite my problem up here as 528 equals, we multiply this t by 550 over t. These t's will cancel off, right? So this would equal 550 minus 10t now, because t times 10 is 10t. So now this would allow us to just solve for t. So we can solve for t. We're going to subtract 550 from both sides. That's going to give us negative 22 equals negative 10. And solve for t, so divide by negative 10. So this tells us that t is 2.2, right? 2.2. That's the time. And this tells us, this is in hours, right? We look at the context of the problem. It says miles per hour. So we know that our unit here is going to be in hours. So that tells us, going back to like our original problem that the train and the plane are both traveling 2.2 hours because they both are going to go the same amount of time. That doesn't answer our question yet, right? Because the problem said how fast are they going, right? So it says find both speeds. Well, we know that the speed is x for the speed of the train, and for the plane, the speed is y. So really we want to find x and y, but we found t. That's okay. We can still find the other ones now by resubstituting this back into our original problems. So I know 2.2 hours is the time. And I'm going to go back to my blue equations over here, and that will allow me, actually I'm going to go back to this equation right here and the second equation that I wrote before I substituted, because that will allow me to find the x and the y now that I have the t, right? So I'm going to go ahead and finish this up. We're going to have 110 equals x times 2.2. Now we can solve for x, so that's 110 over 2.2 is going to be the speed of the train. Oops. And that's going to equal 50. So that's going to be 50 miles an hour. 50 miles per hour, that's going to be for the train. So that's one of our answers. And we need to find the speed of the plane, which means we need to tell what y is. And we can do that by going back to this equation, which says 528 equals y times t. But now, again, we know that t is 2.2, so we plug in 2.2 there. And we divide 528 by 2.2, both sides, of course. And we divide that out, and we get the speed to be 240 miles per hour for the plane. So those are my two answers in this problem. Find the speeds of both the train and the plane. Well, again, this is kind of a long process. There's several other paths you could take to get to those answers, because you could have named the variables different. You could have set up your equations a little bit different. When I start these word problems, I usually start with just kind of the things that I already know. So when it was talking about distance and speed and time, I just kind of started with this basic guideline that relates those three things. And then we had two things there, a train and a plane, and we just kind of wrote out using the formula that we already knew how the distance and rate and time relate. And then we just kind of had to think about, all right, let's make some variables here. What do we not know? And so then we defined some variables, t and x and y, and then we went from there. So it usually has this process of kind of a rough draft, or kind of what is the problem giving us? What are some of the basic equations that we might use? And then you can start to translate it into something more mathematical, more precise, with variables. And then we can start to get down to, okay, now what do we have here? We have a system of equations. And how do we algebraically solve this system of equations to get the variable that I need to uncover to solve for? And so that took us down this path to find t, and then we could plug things back to get our x and y, as you see. So these types of problems take a lot of practice, but the process, really, you want to practice a lot and challenge yourself to even if you struggle with these types of problems, to try them, to go through the process, to think about what you're given, what do you already know, what variables can I create, and really challenge yourself and push yourself to give these a try. And the more you do, the more you get better at that process and that way of thinking. Hope that helps.